Well, good morning to everyone. Thanks for being here. I've been working for about 3 decades on on fabrication technologies in general. And when 3D printing started, I was one of the early starters. I've been working on different technologies there. These are some of the technologies that I have developed in the field of polymeric and metallic 3D printing. And these days, I'm looking at applications of these in different domains, especially in space fabrication. So I'd like to give you a broad overview of how I see the landscape of large-scale 3D printing as I have observed it, and I speculate. Well, in 1994, I basically made an observation. I noticed that all these 3D printing technologies build layer by layer, with very thin layers, of course. And it occurred to me that the only object that humans have ever built in a layer-wise fashion are actually buildings. Bricklaying is a way of layer-wise fabrication. So 3D printing builds layer by layer, but for several millennia, we've been building buildings layer by layer. Right then, it occurred to me that maybe the best potential of 3D printing is in construction. And this building was built about 2,500 years ago with clay and straw. It's in the city of Bam in southern Iran, still standing. So then that was the impetus to my thinking about a process that can build large scale at high speed, and I created this technology that could build with very thick layers and yet maintain very smooth surface. I called it contour crafting because the focus was on the contours. Then I made several demonstrations around that time, and for quite some time I wasn't really thinking about building. I was thinking about large-scale structures of all sorts. And the first little concrete wall that I built got the world's attention. I used some admixtures from the Gusa, the German company, and therefore Spiegel magazine published a paper, and then New York Times, and publicity was amazing. So then I was certain that this is really the direction that I should focus on. So I built larger machines and made other demonstrations. Well, these are some of the fabrication activities that you see: hybrid walls, ceramic objects, very smooth surfaces. I also thought about a hybrid system that would combine other activities with 3D printing. I looked at the fact that with 3D printing, we can build only the shell of the buildings, but buildings are not only shells. There's a lot more that goes into them. And therefore, I thought about automatic reinforcement, automatic plumbing, automatic electrical network installation. And these days, I'm into other integrations of other activities there. So again, I made several demonstrations of other forms of reinforcement, for example, with coil, embedding sensors that are automatically powered by conductive concrete, putting large stainless steel fiber into the system of walls. So this chart was published last year, I guess, and one of my students brought it to my attention. Gave me good feeling to know so many people have been misled by me. But I think I'm very excited about the activity that's going on, and I wish everyone success in this direction. So the focus is on buildings everywhere I see, residential and commercial. And of course, there is a need. According to United Nations, there's a shortage of 800 million homes. And we see the situation with current construction, which is the biggest sector of the economy, and yet is being handled with the most antiquated fabrication ways. And skilled workforce is vanishing, work quality is low, control of construction site is difficult, accident rates are high, construction is the worst job as far as safety is concerned. Waste and trims are high. The environmental impact of construction is pretty bad. Low-income housing, emergency shelters are critical. And finally, all products are fabricated automatically except this building. Just look around yourself, your shoes, your clothes, your home appliances, your cars, everything is pretty much made automatically except the building. So one wonders, why shouldn't this be automated as well? So I see the condition of shelter for nearly 2 billion people. Global warming increases the natural disaster, and of course the condition of refugees is terrible. Look at what is happening in Bangladesh with the Myanmar refugees, and what has happened to Iraqis and Syrians. Just awful. So I've been thinking and imagining about paradigms that would build all kinds of buildings, but I faced the barriers that are really around and should be taken seriously. Construction is a very conservative industry. They really don't want to make very quick shifts, and there are good reasons for that. It has a low profit margin. Competition is pretty stiff. Regulatory barrier is something important. A lot of products don't have this kind of stringent regulation. Of course, human life is engaged there. They have to be so. Major paradigm change requirement with respect to inspection is required. So it doesn't make sense to be able to build a house in one day, for example, but wait 2 weeks for the inspector to come and check different stages of this. Not too many people think about this problem, but that's a very serious problem. It's a very hard thing to automate. There are labor unions, of course, in certain parts of the world. And as I mentioned, at best, we really can impact the cost of building shell with the 3D printing aspects, the part that is building stuff by adding material layer by layer. There's much more into automation. In robotics, we do amazing stuff in factories. My background is manufacturing automation. And we should be mindful of the fact that the 3D printing community is not the first one looking at automating construction. We should go back and look at the 80s, 1980s, and see what the Japanese did, specifically 3 biggest companies, construction companies in Japan, Shimizu, Obayashi, and Kejima. They put billions of dollars on robotic automation, inspired by the success of automation and Seiko Instruments and Toyota. They said, okay, why not in construction? You should read about the consequence. It was not that promising. We don't see those systems around, right? Although several of the individual robots that were made for certain aspects are in use, but in general, the whole paradigm that was thought about did not really succeed. So as for future, I think there is potential in the infrastructure. We have one experience doing some exploratory analysis for building tall towers for Siemens. It was a project that was supported by Siemens. So right now, the process is very costly, and there are ways of automating that we are considering. We built a small-scale model of this, and the feasibility of it has been really tested. It is feasible in about 100-kilometer wind with fresh, unreinforced concrete. We think this can be possible. So when we can do that, we can build all kinds of pylons. One group that is looking at it, the Hyperloop people. But in my opinion, the biggest potential of 3D printing, both in a small scale and larger scale, is in space. People don't take space seriously. They think it's luxury, while we're using the results of space technology on a daily basis. Every time you drive and look at GPS, it's because of the satellites. You make communication calls other countries, it's because of satellites. A lot of TV programs and massive data transfer of computers is through satellites. Every time we do Google search, it goes through satellites. That's space technology. In the future, our life will depend even more on space technology. There is serious attempt in using asteroids in the asteroid belt, using the materials of those, build in space components that we need, building electronics as well as other objects, building the entire server farm and leaving it float in space rather than bring it on Earth that makes so much pollution and takes so much energy. So free energy, free material, no pollution on Earth. And this is very expansive. So in the last 15 years, I've been working with NASA. Yeah, this is a concept, taking material of an asteroid and building stuff with it. This is a technology that I developed. It works in zero gravity and microgravity and can build 3D metallic objects. The surface of this, you can see, is nicer than any laser or electron beam manufacturing system. This is bronze. This is stainless steel. Yeah, there are companies that are now into mining. Seriously, these companies have received good investment. I know several of them. They're real companies that are shooting to go to space, mine the asteroids, mine the lunar and Martian material, and a lot of them are into fabrication objectives. So one project I had with NASA was construction on Moon and Mars, construction of future of human habitats, but starting with basic infrastructures like landing pads, hangars for landers and other equipment. This is precursor emissions, totally autonomous. It's not for people, no habitat yet. So we demonstrated how we can 3D print with waterless concrete that we came up with, just the materials that are out there. This is highly strong structures that are made layer by layer by a version of contour crafting. It's a thermal process. So we could build structures like this out of the in situ material, local material. This particular video shows using microwave in processing and melting the lunar regolith in this particular thing, and layer by layer building objects. The electricity comes from solar panels, and this, as was mentioned, NASA gave us a grand prize in an international competition. Another project that we have had is building horizontal surfaces like landing pads and roads with interlocking tiles. These cannot be monolithic structures of concrete or whatever, because the plumes are so hot that they expand and shatter the lander if it is one piece. So we have to make this out of interlocking tiles, high temperature ceramic tiles. And a new invention that I made in 3D printing is called SSS, Selective Separation Shaping. This is a powder-based method. It's not extrusion-based method. As you see here with concrete, these are like 2 centimeter layers. This is 2 centimeter. In one shot, we make these parts with very thick layers. It's extremely fast. And these are some demonstrations with lunar soil. This is lunar soil, and this is a method of insulation of these. It's a new 3D printing concept. We can do it in 3 dimensions and lock these together in 3 dimensions. So this is centered with microwave, and it's a very hard and high temperature ceramic tile. So in the future, landers don't have to face such a situation. If the lander plume pushes the material away, the dust away, the bedrock underneath, if it is a slant, it gives a chance of lander tipping over. In the future, we can autonomously build these landers, these landing pads, because future landers are going to be much more heavy duty. They're not going to be as small as what we've had. If you want to go for exploitation on Moon and Mars, we're going to take a lot of stuff there, and that cannot be tiny landers. We need strong landing pads. So in 2016, we got another international grand prize from NASA So, of course, there are other future research directions in the future, process innovation. Still, extrusion is not the only way. There are many other ways that we can think about larger scale. And, but right now, all the processes that I know of are limited to extrusion. Material research, of course, a lot of interesting stuff are going on. A lot of very knowledgeable people, some of them who are here, I see, are engaged in very intellectually stimulating research and development in the field of materials. On the digital side, building information modeling and integration of system with BIM and Internet of Things is another direction that we can think of for future of 3D printing. More recently, in early 2017, the Austrian company Doka invested in our technology, and in May of this year, 2017, we started the company Contour Crafting. It's near Los Angeles International Airport. And our goal is to focus on 3 directions. One is building technology, the other is infrastructure, and finally space technologies. With that, I thank you for your attention. You see, I finished on time.
Thank you very much. Thank you very much.
Henrik was so paranoid, he kept sending email, this is too long, you have too many slides, you're not going to finish it.
For the first time in history, we have a conference that's ahead of time. That's, I think that's never happened before. I actually have a few questions for you, if you don't mind.
No
now
problem.
That we have a good time for that. You developed this concept of 3D construction nearly 20 years ago.
23 years.
23 years ago, that's
Right.
very impressive. But first now, 23 years later, the Doka Ventures has invested in your company. Why not earlier than this? Why first now?
Right. Well, if you look at the history of disruptive technologies, you'll notice that none of them have had an easy time happening. And there are very good reasons for it. I'll give you one example. Telephone, invented by Alexander Graham Bell. This happened at the time of telegraph, right? You would imagine that when people had telegraph, when telephone happens, this is a slam dunk invention. They're going to jump on it and it's going to commercialize immediately. 15 years, Bell kept banging his head against different doors. Nothing happened. Nobody paid attention. There's a famous quote by the president of Western Union who said, when people have telegraph, who needs telephone? And he was a great businessman. He was right. You're talking about a time that there was no wire going into buildings. People were using kerosene to light their houses. There was not even electricity in the buildings. So if in order to send, to call somebody, you had to first send a telegraph, right? To ask them to come to a telegraph station in the other city. And by the time you say, hi, how are you? Several minutes pass and the guy could have sent many telegrams. So only rich people could have afford that, and that public locations were not convenient for rich people to go there, so it wouldn't be a business success. And Graham Bell started himself creating a company, then wiring a hotel room to the next hotel room, and gradually demonstrated how this thing can actually happen. When internet happened, I remember it was during my time, I was one of the non-believers. You know, how could this possibly be so, that everybody would have a website somewhere? It happened so fast. So in this case, also people thought about all the barriers against this. And of course, they didn't think about the possibility, technical possibility. Now, Doka is into formwork. They make formworks, very sophisticated formworks. They're automatically raised and all that. The biggest building in the world, Burj Khalifa, has been built by their formwork. So they're into technology, they understand it. But accepting the fact that instead of poured concrete, when you pour the whole, you make a whole monolithic wall with all the highly, densely reinforced cage in there embedded, how could you possibly use this tiny layer by layer approach? How fast is it going to be, and how credible it's going to be with respect to functional capabilities? So, of course, they contemplated a lot on that. But they know that if this thing happens, it's a threat to their business. If 3D printing is successful, there's no need for formwork.
So that's why they invested in you now.
Basically, right.
To keep your enemies close, right?
Yeah, as we made more and more demonstrations, they saw. But this is such a good question that was asked. It deserves to elaborate more on it. The reality is that still there is doubt if this is going to work. You know, several people have been building stuff. I bet nobody has made much money out of all that, right?
I doubt that.
This has not taken over, right? We have to think about it. Why? We're going to try. We're going to go forward and be optimistic, but we have to accept the fact that it may not.
But that also leads me to my next question: is why are there so few 3D printed buildings in the U.S.?
So
compared to, for instance,
because
Holland.
Okay, I am in the U.S. Perhaps if I were somewhere else, I would have printed something for demonstration much faster.
Why not?
The encouragement is not that great in the U.S., right? I could not even build inside my laboratory in Los Angeles, right?
Are we talking about legal? We're talking
about regulatory stuff. What happens if there's an earthquake and the students get killed? Stuff like that.
Oh, you're also worried about people getting killed in the U.S. all the time. Maybe take the guns away first. That's another story for another time.
Regulatory barrier is strong.
I get that.
But neighboring country, Mexico, they keep saying, "Come here, build for us. Come here, you know, we need this." That's the reason.
Yeah, I get that.
But also, I sat back and I looked at others building in other countries.
And let them fail, so you could figure out what to do.
I mean, it wasn't very encouraging for me, to be honest with you.
Does anybody have a question from the audience? Yeah, sir? Loud and clear, please. Let me repeat the question if you didn't hear it. There's a need for low and medium cost building, and the question was whether you thought that this was the technology to solve that problem, or it could.
Yeah, initially, of course, if you look at my TEDx talk, I'm one of the advocates, very strongly proponent of this approach. I'm a believer in automation. I don't think people will build anything by hand in the future, right? So either this or something else. The way of construction, the way it is being done, is going to change. There's no question about it. People are not going to do anything that is physical. But the closer I got to the problem, I noticed that it is not an easy challenge. Conventional construction is well streamlined. They use cheap labor. They're very flexible. They can build anything, right? You don't have limitations there. They almost have no tools, and anybody with a wheelbarrow and shovel can start a construction company.
And they do. Well, actually, that's what
right?
Do. I met many of them.
Right. So very low overhead with respect to equipment, and then you're asking them to buy or lease expensive equipment. One reason the Japanese failed was just that, you know. Yeah, they got rid of low-paying construction workers, but they had to hire a lot of experts to maintain those robots and program them and so on. It has to get to a balance, and it will, I believe. Now, again, I keep saying, I'm not sure if it's going to be 3D printing, but automation of construction will happen. There's no question about it. 3D printing will have its role to a certain extent. But there's a lot of hype generally about 3D printing, like in the smaller scale 3D printing. People thought that, 3D printing, or some people still think 3D printing is going to change everything.
Solve the whole thing, like the whole world, right?
Right. It's not true. You know, you're not going to build railroad tracks with 3D printers. It's silly thought. I-beams with 3D printers. No, there are much more efficient ways of doing it, and you can never build an I-beam that is as strong as the currently rolled I-beams and steel mills by 3D printer. Even the smaller metallic things that we build don't match what we conventionally do. in manufacturing process.
Okay.
So nothing is going to be obsolete by 3D printing.
Can I have one more question? Yes, sir. It's the last question for you, sir, but thank you very much. Over there, sir. Yeah. Loud and clear.
You're talking about the economy of the 3D printing. You didn't talk so much about material use. From what I saw, there are not really any initiatives that would reduce the material use, because I think the advantage of 3D printing would be creating more complex shapes than, for instance, a steel mill is able to, thereby reducing material use and thereby reducing the cost, because, I mean, 3D printing will take off when the cost is lower than conventional building.
So the question is whether the economy on 3D printing is one thing, and also the material use. You didn't get, the question was, so do you have a comment on what we're going to do about the amount of material used to do 3D printing?
Material consumption.
Yeah, the consumption of material.
Structures, yeah.
Oh, so when 3D printing uses less material. Is that what you're saying? Is more effective in the usage of material, therefore there's saving in the material side?
As I see it, currently not. But if there are also initiatives in terms of creating, I don't know, for instance, microstructures that would be much lighter and so on.
So in the field of manufacturing, we have manufacturing design, we have a field called topology optimization. So with the same material, the same object that you want to make, you can make the internal structure such that you use the least material. But they are very difficult to materialize, to build with conventional technologies. For example, look at the human bone. It's structurally very amazing. When you go inside of it, it is not solid anymore. It is basically a bunch of trusses, hollow structures that in the course of evolution have been optimized with the least material, calcium-based material, with the least weight. You make the strongest possible bone structures. Yeah, the same concepts could apply to buildings, but there is a restriction here in case of buildings, that how do you really inspect those buildings, you know? Because when something is made out of millions of little trusses internally, the inspection process is you know, you either have to make a copy of it first and demolish it, put it under hydraulic presses and whatever, demonstrate that this is strong, and then follow that, and then prove that this is exactly like that. So, yeah, there are some complexities, but theoretically, you're right. Material waste is less. You can, even when you use curvature, you just give a lot of strength to a wall. Any curved wall is stronger than planar walls. Definitely true.
Thank you very much. Give a big round of applause to
Thank
Behrokh
you.
Khoshnevis. Thank you so much, sir. Thank you. Very good.